Today we'll be discussing dilations, and dilations are another type of transformation that you can perform on polygons on a coordinate plane. So a dilation is the enlargement or reduction of a shape on the coordinate plane. And remember, enlargement means the shape is going to get bigger from the original or compared to the original. And the reduction means it's going to get smaller. And the other unique thing about dilations is that all dilations are going to be proportional to the original. So because they're proportional, that means we are using a scale factor to determine how much larger or smaller we're going to be getting. So if your scale factor is less than 1, or in other words, a fraction, that means that we are performing a reduction. It's going to get smaller. And if your scale factor is a whole number or greater than 1, then that means that you're going to be performing an enlargement. So a good example for a scale factor that's a fraction would be like a half. So that would be a reduction because your shape is going to be half the original size. If another example for an enlargement would be something like maybe it is twice as big. So we would be multiplying by 2 in order to get our shape twice as big or 2 times larger. So let's go ahead and take a look at how we graph these. So the first thing, okay, so we're going to go ahead and graph the original. So m is at 3, -1. And n is at 2, -2. So pretty close together there. And then s is over none and up 4. All right, so it says that we are going to apply a dilation that is using a scale factor of 2. So if the scale factor is 2, I'm going to be twice as big. So this is going to be an enlargement. And basically all I'm going to do is multiply all of my ordered pairs by 2 to double the size. So m prime would be 2 times 3 is 6. 2 times -1 is -2. And n prime is now going to be 4, -4. And s prime is going to be 0, 8. And then you just go plot the points. So you'll go over 6 and down -2. And there's m prime. And then n is going to be over 4, down to -4. And then s will be over none, up 8. There's s prime. So you just doubled the size of your original triangle. Now let's come over here. We're going to try another one. We're still going to graph our original, so let's go ahead and do that. We're going to graph triangle JKL, so that is over 3, up 8. And K is over 10, up 6. And L is over 8, up 2. So this time the dilation scale factor is a half. So I am going to be multiplying all my coordinates by half or taking half of each, and this is going to be a reduction because my scale factor is less than 1. So now I'm going to be getting smaller. So if I'm going to go ahead and take half of all of my coordinates. Now, if you want to multiply by 0.5, you can, but I think just taking half of each number, usually it works out pretty evenly. So half of 3 is 1.5, or 1.5, and half of 8 is 4. And then for k prime, half of 10 is 5, and half of 6 is 3. And then for L prime, half of 8 is 4, and half of 2 is 1. So we'll go ahead and plot that. So J prime is at 1.5. Now when you go over 1.5, you go over to 1, and then you just go halfway in between 1 and 2. And then you're going to count up 1, 2, 3, 4, and put your point right there, right in the middle there. And that's going to be J prime. And then K, you'll go over to 5 and up 3. There's K prime. And then L prime will be over 4, up 1. And you dilated your triangle. So now the original triangle, or that new dilated triangle, is half the original size. Next, what's the scale factor? So sometimes you'll be given the picture of both the original and dilated triangles or polygons, lines, whatever they are, and then you'll be deciding what the scale factor is. And the scale factor, remember, it's proportional. So we are comparing, it's like a ratio. We are comparing the dilated coordinate, so the new, compared to the old or the original. Okay? So all you need to do is look at the x values. So if you're going to come down here and take a look, we are going to put the dilated, which is this one right here on top. And so x prime, the coordinates are over to -2 and up 1. And so the x value that I care about is -2. And then I'm going to come over here and look at the original. And the original was -4. 2. Now, as you can see, those are my two x values, and -2 over -4 equals 1/2. So this was a reduction. And you could probably already tell that from the original compared to the new. Also, you don't have to use the x values. If you notice, you could also use the y values. And look, if you put 1 over 2 dilated compared to old, then you would get 1/2. So either way will work. Okay, so for the next one here, on the for the next one, the blue is going to be your dilated. So we're going to call that H prime right there. And then the green triangle is your original. That's your H. And so H prime, the ordered pair, is 5, 5. And the original is 3, 3. And so if I'm looking at just either x or y will work like we said. So it looks like the scale factor is 5/3. Or in other words, 1 2/3 times bigger, because remember we went from green to blue. So that is going to be an enlargement. So now let's look down here. Sometimes you'll have a couple word problems, and we're talking about a dilation here that says the pupil of Josh's eye is 6 millimeters in diameter. His eye doctor uses medicine to dilate his pupils by a scale factor of 3/2. Find the new diameter once his pupil is dilated. So basically we're doing kind of like what we did for the front. We're using our scale factor, which is 3/2. And the other information we need is how big his eye is right now, which is 6 millimeters. And so all we've got to do is multiply 3/2 times 6 will give us 18 halves, or 9. So we know we did this correctly because 9 is 3 halves, or in other words, 1.5 times bigger than 6. Okay, and remember, when you dilate your eye, you are getting bigger, so we know that that makes sense as well.